Write down the topic, main topic, horizontal circular motion. Horizontal circular motion. Horizontal circular motion. So we have to talk about the horizontal circular motions. What are this horizontal circular motion? When vehicle take the bend, circular bend, is a horizontal circular motion. When an object the connected to the string and we are rotating in a circular path, it's a horizontal circular motion. So we have to talk about the horizontal circular motion, right? Right now the topic horizontal circular motion. There is it's a very easy case. There is a methods to get that problems. Write down. There are three steps. There are three steps. There are three steps which follow to solve horizontal circular motion problems. Horizontal circular motion problems. Horizontal circular motion problems. They are only in the path. Then in example we can discuss that thing. Okay. Number one. Clearly marks the force. Clearly mark the forces. Clearly mark the forces which are acting on the object. Which are acting on the object. In a circular motion. In a circular motion. In a circular motion. Right? In a circular motion. In brackets, weight, tension, comma, reaction, comma, frictional, friction, comma, gravitation force, etc. Close the bracket. Never mark the centripetal force or centrifugal force. We are discussing centrifugal force after the end of the circular motion. Right. Write down number two. Consider the force equilibrium. These are steps. Okay. Consider the force equilibrium. Along the vertical direction. Force equilibrium along the vertical direction. Number three. Apply F equals MA. Number three. Apply F equals MA towards the center along. Horizontal direction. Towards the center along horizontal direction. Right. We are discussing the example, then you can get the idea about this. They are steps. Correct? steps තමයි කියලා හරි. Write down the examples. Number one, the circular motion of an object, which placed on a disc which rotating horizontally which rotates horizontally. Right. In this case, we are discussing there is a disc. It rotating with omega. Right. We are placing an object top of the surface. Right. When we are placing like this, there is a radial component. There is a force. We have to mark the force. Right. We can mark there is a mass mg, therefore weight. The reaction force. While it rotating, there is a frictional force. Apply the centripetal force. Right. Okay. And an object අපි diagram එක දාන්න කලින් කියමු. හරි. An object of mass m is placed on a surface of coefficient of friction simple mu when the angular velocity of the disc is gradually increases. Right. Okay. Draw this diagram. Then write down. For this case, there is a 3 steps. What we are saying, there is a 3 step. First of all, we have to mark the forces of the object. Right? Forces of the object. Then we have to take considering vertical equilibrium. What is the vertical equilibrium? That's R equals to the mg. Okay. The second one is okay. Then we have to apply F equals ma to the center direction. Okay. Then we apply F equals ma to along the center. Because ma along the center. We can apply F equals ma. That is in this direction. When we apply F equals ma, what is the F. What given by F? F is given by the friction. The friction is given by F. Friction equals to the M. What is A? Acceleration. Which acceleration? Along the center direction, what is the acceleration? Radial acceleration. Radial acceleration. What is the radial acceleration? Omega square. Omega square. Omega square. This is number 1. This is number 2. Right? Write down that term. We got R equals mg. R equals mg. And also we got F equals m omega square R. Okay. Then write down at a certain moment, the object will be on the verge of sliding at sliding full stop. At this moment, at this instant, the centripetal force required for then at this moment, at this instant, the centripetal force required for the mass symbol M to engage in a circular motion. To engage in a circular motion is provided by the limiting static frictional force. Limiting static frictional force extracted on the mass by the surface towards the center of a circle. Right. In this case, center of the circle. In this case, when the this plate or disc is rotating in the rotational, it is in rotation motion. While it rotating, the object is in a circular motion. When we increase the velocity of a disc, this going to the limiting equilibrium. Why? When we speed up this disc, it is sliding from the disc. For that, in equilibrium position, limiting equilibrium position, the force acting along this one is limiting frictional force. Only the limiting frictional force acting. Because of that, the limiting frictional force is F. You know what is the F? F limit means F limit equals mu limit R. Mu limit R. Right? The R equals to mg. In first case, F equals mu R equals mg. In second equation, we can tell F equals m omega square. This is this omega is the, what is that? Maximum velocity, maximum angular velocity, which can rotate before the sliding of the object. ඒ කියන්නේ අපි මෙයාව rotate කරන maximum speed එක. ඒකට වඩා වැඩි වුණොත් එහම මෙයා විසියලා යනවා. Right? It's sliding off. Right? F equals F, it is in limit. Limit equals m omega square. This is maximum r. Right? This is maximum one. Right? The F limit is mu mg m omega square max r. Omega square max mean mu g over r. Omega max mean mu g r, root of the mu g r. This is the equation. When object having a, when disk having a omega greater than to the omega max, that means omega greater than to the mu g r වල root එක. Object will slide. Object will slide. Okay. Write down this one. It is the first example. Write down the problem. Find the minimum coefficient of friction. Find the minimum coefficient of friction between the table and the mass. Table and the mass. For the mass, simple m kept at a distance of 9 meter away, from the center of rotating disc, which rotates T r radius minus 1, as shown in figure. Right. Radius is the, write down, radius is the 0.8. Okay, 0.8, not 9 meter, 0.8, 0.8 meter. Right? The friction, we have to find the friction mu while it rotates like this. Point r equals 0.8 meter. Right? That's it. Okay. Find it. It's very easy one. We have to find it. Find it. For this case, we can find using substituting that equation, but we have to know how to get the equation. the omega max equals to the mu g over previously we derived this one, but we have to memorize how can we derive this one. Okay, the omega maximum equals to the 3r radius minus 1. 3 mu g means 10, r means 0.8. That means we are we have to get the square of both parts. So 9 equals mu equals 10 into 0.8. Mu equals to the 9 into 0.8 over 10. Right? That means 72 7.2 over 10, 0.72. This is the mu value. This is the mu value. Okay. The mu also, right? They are asking mu. Write down the second example. Second example. The motion occur when a vehicle take a bend. The motion occur when a vehicle take a bend. Consider this example. When vehicle take a bend. But when vehicle take a bend, as an example, we can take like this. This is the back side of this car or the front side. Okay. Stay in the bend. Stay in a bend. Right. While taking the bend, there is a force mg and r, reaction force, but there is a frictional force. It is a centripetal force. It is a centripetal force that required to maintain the circular motion. Maintain the circular motion. Right down. The required centripetal force. Given by the frictional force between the tire and vehicle. Between the tire and the vehicle. Right. Draw this diagram. Okay. Write down. We have to take in circular motion. I have previously I mentioned there is a method. First of all, we have to mark all the forces of the object. Then we have to take the vertical equilibrium. Considering vertical equilibrium. What is vertical equilibrium? R equals to the mg. It's okay. R equals to the mg. Then we have to apply F equals ma. Apply F equals ma to center direction. F equals ma to the center direction. F equals m. A means F equals to the friction. Friction equals m. A means the radial acceleration. Radial acceleration. What is the radial acceleration? The vehicle is passing with v velocity. The radial acceleration is not omega square. We get in v square over. Why? The vehicle having a velocity. Vehicle having a velocity. Right? Therefore, F equals to m v square over v square over. Right? Right now, this is number 1. This is number 2. Number 1 and this is number 2. Right. Then write down when capital V increases, when simple V increases, the velocity increases, the friction F also increases. The friction F also increases. When friction reach to its limiting frictional force, the maximum speed may occur. Maximum friction is to F max. F max means F limit. What is F limit? F limit equals to the mu R. Mu limit R. From first equation, we can substitute F limit equals mu R equals mg. Then the second equation, we can get F limit as m p square maximum speed over R. This is number 1. This is number 2. 1 equals to the 2. We can get mu mg equals m v square max over R. Right. Mu g R v square max. V max equals mu g R root of the mu g R. Right? This is the equation. Okay? Write down it. Okay, then write down when mu increases, Vmax also increases. In brackets, when roads in dry condition. Close bracket. So when roads in dry condition, the mu is increased. The Vmax also increased. In the dry times, we can drive the car with some maximum velocity. It having a velocity greater than to the rainy season. In rainy season, the roads are in the not rough like dry season. හරි අපි සාමාන්‍යයෙන් අර පාරවල් වල වතුර වැටුණාට පස්සේ ඒක නිකන් ස්මූත් සර්ෆේස් එකක්. ඒ කියන්නේ සමහර වෙලාවට ගොඩක්ම මේ ෆ්‍රික්ෂන් එක අඩු වෙලා තියෙනවා. එතකොට එතනින් ගියොත් එම් වාහනයක් එයාලා ඉස්සරහට ස්පීඩ් එකකින් යන්න බෑ. එතකොට හැප්පෙනවා. ඒ කියන්නේ කැරකිලා යනවා. හරිද? ඒ ෆ්‍රික්ෂන් එක නැහැ. ෆ්‍රික්ෂන් එක අඩු වුණොත් එහෙම කැරකිලා යනවා. හරි? මෙහෙම යනකොට මේකේ වතුර වගේ තිබ්බොත් එහෙම මෙහෙම ඉස්සර යනවා. හරි? සයිඩ් වෙනවා. Right. Then when mu decreases, Vmax also decreases. Vmax also decreases. In brackets, road in wet condition. Road in wet condition. Road in wet condition. Road in wet condition. And then if the speed of the vehicle increases above the maximum safe speed the vehicle cannot move along the circular path because insufficient centripetal force dash frictional force because of the insufficient centripetal force or friction force. Right. Then write down the example. A vehicle move along the circular bend. Which having a radius 20 meter. And limiting frictional coefficient equals to the 0.2. Find the maximum speed level. Of a vehicle should be maintained in the circular motion. Right. Find out.
Sir,
We can apply P equals mu gr. But we have to memorize Vmax equals mu gr. Root of the mu gr. 0.2, 10 and the 20. Yes. The radius is 20 meter. I tell the radius is 20 meter. Radius is 20 meter. The 20 meter. equals matriarch, mu equals 0.2. That means this is 40 root 6.32 means. Yeah. Your answer is correct. Yeah. Okay. 6.32. Then write down another example. Number 3. Lean angle. L-E-N, L-E-A-N, lean angle. What mean by lean angle? L-E-A-N angle, lean angle. It is the angle of when we ride a motorcycle or a cycle. When we take the circle or when we take the angular row, we are we not write like that. This we not write like this. We cannot take the bends like this. Why? We cannot take the bends like this because there is friction force acting along this direction when we take the bend, and there is a mg and the reaction force coming from the flow. This. So when we take the bend, we have to angle it to the direction of the bend like this. We have to angle it to the bend. Why like that? There is a lean angle. Lean angle. Right. Write down. Write down. Consider a situation where a motorcycle try to take a motorcycle try to take a motorcycle try to take the curve without leaning to the curve. Leaning to the curve. Leaning to the curve. Right. Abhi, when we ride the scooter, right? We are taking a curve road. We did not lean it to the ground. We take the like this. We only rotate the handle. Because of that, we are getting thrown off or rotate, right? We cannot take the angle. දැන් අපි බයික් එක යනකොට අපි බයික් එක නමන්නේ නැතුව අපි බයික් එක මෙහෙම හරවන්නේ නැහැ. ඇයි බයික් එකේ යන ගමන් බයික් එකේ මේ පැත්තට මෙහෙම හරවනවා. හැබැයි අපි බයික් එකේ යනකොට බයික් එක නමලානේ යන්නේ. හරිද? නමන්නේ නැතුව අපි නිකන් හැරෙවුවොත් එහෙනම් මොකද වෙන්නේ? අපි පෙරලා වැටෙනවා. හරිද? පෙරලා වැටෙනවා. හරිද? ස්කූටර් එකේ යනකොට කට්ටිය මෙහෙම කරලා එකපාර හැරෙවුවොත් එහෙනම් මොකද වෙන්නේ? පෙරලා වැටෙනවා. හරිද? ඉතින් අපි බයික් එකක් යනකොට අපි මේ පැත්තට නමනවානේ. වංගුවක් ගන්නකොට මෙහෙම නමනවා. හරිද? ඒක තමයි මේ තියෙන්නේ. මේ තියෙන්නේ නිකන් අර යනකොට. මේ වංගුව ගති නමනකොට. හරිද? ඒක තමයි ලීන් කරන්නේ. හරි? right. මෙන්න මේක දාගන්න. He is trying to take the curve without leaning. Right? Let's talk about this situation. පළවෙනි එක දාගන්න. The center of gravity is G. First diagram only. I will show it. Only the first one. Right. Time take without linear. There is a movement. Why? F create the movement. Because of that, it rotates. Right? Write down. Since the capital R and Mg, since capital R and Mg, since capital R and Mg, linear, 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 and there is no momentum around. There is no movement around. Movement around. Movement would mean movement around capital G. Capital G. Center of gravity. Center of gravity. Gravity. But there is a movement produced by. But there is movement produced by a frictional force. A frictional force. A frictional force. Because of this. Because of this. Because of this. The motorcycle flips off. The motorcycle flips over. Flips over. Flips over. Next rule again. Flips over. When motorcycle bends towards. When motorcycle bends towards. Bends towards. The bend. The bend. Mg and R. Mg and R. Not linear. Not linear. And they are act. Maybe not linear. Mg and R is not linear. They are act as a force couple. They are act as a force couple. They act as a force couple, and it balanced by a moment of friction force. It balanced by a moment of friction force. Right. මෙන්න මේ වගේ case එකක් තියෙන්නේ. Right. හරි diagram එක දාගන්න like this case. The angle to the horizontal is the line angle R at theta. The bend mass Mg acts on the G, and it creates the frictional force which acts in this direction. Right? In this direction, the height of this is simple h. Right? Like that. The distance to this one is a. Right? It also can be marked in this case, but it's not clear to you. That's why I marks this diagram. Write down these two diagrams. Write down these two diagrams. The both are same, huh? This is only both are same. Huh? Right. Okay. Right. We can apply in the most of the case we have to apply if we vertical equilibrium, then we can apply vertical equilibrium. Considering this case we can apply vertical equilibrium. What mean by vertical equilibrium? Considering vertical equilibrium, we can tell considering vertical equilibrium, we can tell R equals to the mg. R equals to the mg. Right? Most of the case we are using like that steps. Huh? Then we can tell. Apply F equals ma. Apply F equals ma to the center. What is the when I apply F equals ma? F equals to the mp square over r. F equals to the mp square over r. Right? At this case. Then take a look at we have to take movements of A point. Take this point as A point. Write down it note. This is A point. We have to take the moment around the A point. Take the moment. What? This is in equilibrium. When we take in the moment, we can take mg and f. mg into A equals to the f into h. I tell you. We have to take the moment considering movement around A point. For the equilibrium movement around the toe A equals moments equals 0. Right. That means mg into A, line of action of mg acts the perpendicular distance of A. mg into A equals to what? When we take the moment of this point, f into h, f into h, f into h. Right? Then we can apply mg into A, f into h, mb square over r into h. Right? Okay. We can apply considering movement around A point. mg into A equals f into h. Then I know mg, this one, okay. Then we can simply get the values p square over gr equals A into h. Right? Okay, write down, write down. Then tell what is mean by A over H. We can take this triangle A H theta, right? We can simply tell, we can simply tell tan theta equals to the what? Tan theta equals to the A into H. A into H. Right? Therefore, we can tell tan theta equals to the V square over GR. Right? This is the lean angle. This is the lean angle. What mean by that? Triangle. This triangle. So triangle is this one, this triangle. Consider this triangle A into H, tan theta equals to the what? Opposite or adjacent, right? A over H, right? When V increases, tan theta also, but tan theta also increase, no? අපි වේගෙන් આવොත් එහෙම වංගුවක් ගන්න ගොඩාක් ඇන්ගල් කරන්න ඕනේ. හරිද? අර ෆෝමියුලා y මොකද්ද? අර y ස්ට්‍රේස් වල එහෙම ගොඩාක් වේගෙන් ඇවිල්ලා වංගුව ගන්නකොට ගොඩාක් ඇන්ගල් එක වැඩි කරනවානේ. හරිද? එතකොට අපි ගොඩාක් ඇන්ගල් එකක් තියෙන වංගුවක් ගන්නකොට හරිද? ඒ කියන්නේ අපි දැන් හිතන්නකෝ r කියන එක නා. r කියන එක නා මේ මොකද්ද? රේඩියස් එකනේ. මෙන්න මේ කර්ව් එකේ රේඩියස් එක. කර්ව් එකේ රේඩියස් එක අඩු වුණොත් එහෙම tan theta increase වෙනවා. When r decreases tan theta increases. Therefore දැන් අපි එක පාට ළඟ වංගුවක් ගත්තොත් එහෙම tan theta increase කරන්න ඕනේ. ළඟ වංගුවක ගොඩක් නමන්න ඕනේ. The r is higher. r කියන එක නම් ගොඩක් වුණොත් එහෙම theta කියන එක decrease වෙනවා. ඒකෙන් කියවෙන්නේ මොකද්ද? අපි ගොඩාක් දුර වංගුවක් ගන්නකොට theta අඩු වෙන්න ඕනේ. tan theta අඩු වෙන්න ඕනේ. ඔච්චරයි guess එක. හරිද? right up down. When v increases, theta also increases. Theta also increases. When radius of the bend decreases, theta getting increases. Right. Write down another example. Number 4. Inclined bend. Inclined bend. ඒකේ Roman number 1 දාගන්න. Inclined bend number 4. Roman number 1 without friction. Roman number 1 without friction. Right. මෙන්න මෙහෙම inclined plane එක move වෙනවා vehicle එක. right? Inclined plane එක vehicle එකක් move කරනවා. අපි මේකේ forces mark කරොත් එහෙම R and mg. Rx 90 minus theta. This is 90 minus theta. This is theta. Rx theta equals to the vertical, right? Like this. We have to clearly mark the angles and forces. This is 90 minus theta. This is theta. Therefore, this is theta. There is no friction. Huh? There is no friction. But this the vehicle get the bend radius r with radius similar. Right. Okay. The centripetal force. What? Who given the centripetal force? When any object in a circular motion, there is essential thing is the centripetal force. The centripetal force given by the component of the r. See, this direction r cos theta, this direction r sin theta. R sin theta components give the centripetal force. Write down. Write down. Centripetal force which required. Centripetal force which required to maintain the circular motion. To maintain the circular motion is provide the frictional force, provide the reaction force, provide the reaction force between road and the vehicle. Right. Okay. Look at this one. This is a circular motion problem. We have to mark all the forces on the vehicle, the object. Then we have to apply what? Considering vertical equilibrium. Considering vertical equilibrium, we can tell R cos theta equals to mg. This is number one. Then apply F equals ma to center direction. F equals ma to center direction. R sin theta equals m p square over r. This is number 2. We dividing second one from first one, right? Therefore, r sin theta, r cos theta equals to m p square over r ng. Right. The answer is tan theta equals to p square over gr. This is the equation. Only there is only one speed that can be traveled. when we use not use in the friction. Without friction, there is one velocity, right? There is one velocity. Write down. Write down. When the angle theta change, the angle theta changes. The velocity v also changes. The velocity v also changes. V also changes. Remember, when there is no friction, there is only one speed. There is only one speed which only which can which one speed which can travel in a bend but there is a range of speed that can be seen when using the friction. Right. Friction එක use කරොත් එහෙම අපිට range එකක් එනවා. Right. Right down. දැන් මේකේ friction එක කියලා කියන්නේ මෙයාට යන්න friction එකක් තියෙනවා. මේ පාරේ යන්න friction එකක් තියෙනවා. Slightly friction එක තමයි මේ අපි කියන්නේ. හරි? ඒ කියන්නේ මෙයා මේ පැත්තට move වෙන්නේ නැහැනේ වාහනේ යන්න කොහොමද friction එකක් ඕනේ tires වලට. වාහනේ tires වලට කොහොම friction එකක් ඕනේ. දැන් මෙයාගෙන් කියන්නේ මේ පැත්තට friction එක නැහැ කියලා. හැබැයි friction එක තිබ්බොත් එහෙම යන්න පුළුවන් speed level limit එකක් තියෙනවා. ඒ කියන්නේ range එකක් තියෙනවා. Right? We are discussing that. Right. Now write down number 2 with friction. Without friction. Number 2 with friction. Right. In that case, write down. There is a range of speed. That can be seen. When using the friction travel along the inclined plane. Right. Simple A part. Write down the simple A part. Maximum speed. Vmax. Simple A part. Maximum speed. Vmax. Maximum speed Vmax. Right. Write down in that case. When vehicle travels with high velocity, the friction acts friction acts down to the downward direction. Friction acts downward direction to the slope. To this slope and provide the centrifugal force. Centrifugal force. Provide the centrifugal force which required to maintain maximum velocity. To maintain maximum velocity. Right. Let's talk about this example. Right. In this case, it is moving very fast in the circular motion. Like this. The frictional force, it's very fast. The frictional force acting along this direction, F, this F max, right? And also the reaction force acting like this, and also mg acts like this. Then we have to mark the angles, angles. This is theta. This is theta. The velocity v. Okay. Draw this diagram. Draw this diagram. Draw this diagram. Right. For this case, we have to take what is the Vmax, right? Okay. This is the circular motion. We only use the 3 steps. We have marked every forces. Then we apply vertical force equilibrium. Vertical force equilibrium. When we apply vertical force equilibrium, what is the vertical force equilibrium? R cos theta equals to mg. Not only mg. Why? The frictional force acting on this direction. We have to get that also. F max sin theta. See, F max sin theta. R cos theta equals to mg, not mg, F sin theta. F max sin theta. That means we can take F max as mu r. Then we can simply say R cos theta equals mg mu r sin theta. Mu r sin theta. Okay. Then I get this term to this direction. R cos theta minus mu r sin theta equals mg. This is my first equation. This is my first equation. Okay. This is my first equation. Then I apply F equals ma to the center. F equals ma to the center. The forces are r sin theta. See, you can get that. What are the force? R sin theta acts to this direction and F max cos theta acts to this direction, right? R sin theta, F max cos theta plus F max cos theta. This is travel along V, along a circular path with the velocity. That means V equals F equals ma. We apply F equals ma. Forces are okay. M A equals V square over R. V square over R. This V is the maximum velocity. Right. Then I arrange this one. R sin theta plus mu R cos theta equals M V square max over R. Right. This is the second equation that I get from when applying F equals ma. This is the second equation. Write down this first equation and second equation. Write down this one. First of all, we have to divide it first. Second equation from first equation. I wrote mv square over r over mg. R sin theta means r sin theta plus mu r cos theta. R cos theta minus mu r sin theta. Then the m terms are cancelled out and r terms are cancelled out because why? Yeah, equal terms of right. Therefore, v square max over rg equals sin theta plus mu cos theta minus mu sin theta. Therefore, v square max equals gr sin theta plus mu r cos theta over cos theta minus mu r sin theta. So we can get v max equals this one. Okay, right. Write down. Right. Then write down. Then write down the B part. The B part minimum speed. B part minimum speed. Right. So okay, maximum speed and the second B part minimum speed. Tell me when an object, when a vehicle travel along the circular path with the minimum speed. What is the force? What is the force acting on the when write down minimum speed. The frictional force, act upward direction when vehicle having a minimum speed and it supply the low centripetal force. Right. Like this. මේ vehicle එක minimum speed එකකින් යනකොට එයාට act කරන force එක කොහොමද තියෙන්නේ? එයා තියෙන්නේ upwards downwards. මෙයා මෙහි පැත්තට ලිස්සන්නේ. එහෙනම් upward direction එකට fmax කියන එක කියලා ලියන්න ඕනේ. යන්තම් මෙයාට යන්න පුළුවන් ස්පීඩ් එක තමයි බලන්න. Right? The reaction force acting in this direction, the mass mg acts in this direction. We have to mark the forces. The theta, this is 90 minus theta, this is theta, this is theta, right? Theta acts in this direction, theta acts in this direction. The forces, all the forces can be marked like this, right? Okay, we have to consider these forces, right? Write down, first of all, mark all the forces and apply F equals ma, F equals ma to the center direction and apply force equilibrium in give the answer. Right. In that case, we have to use all of the R, mg and F. Right. Considering vertical equilibrium, considering vertical equilibrium, R cos theta equals to the R cos theta plus F sin theta බලන්න පේන්නේ සමහර ලාවට මේ R cos theta F sin theta මේ F max තියෙනවා mg තියෙනවා R තියෙනවා F max sin theta equals to the mg බලන්න වෙනවද කියලා this is F max R cos theta plus mu R sin theta equals to mg. This is number 1. This is number 1. First equation. Right? Then apply F equals ma to the center. When applying F equals ma, what is the forces? R sin theta මේ පැත්තට R sin theta මේ පැත්තට F cos theta මේ පැත්තට. එතකොට center එක කියලා කියන්නේ මේ පැත්තටනේ. එතකොට F equals ma දැම්මොත් එහෙම R sin theta minus F max cos theta equals m b² max min over R. Right? That means R sin theta minus mu R cos theta equals m b² min over R. Is coming over R. Right? This is number 2, the second equation. The second equation. Right? I am dividing second equation with first equation. I am dividing second equation with first equation. m² min over R over mg equals what? R sin theta minus mu R cos theta R cos theta plus mu R sine theta. Right? M to M cancel out. P square min over GR sine theta minus mu cos theta over cos theta minus plus mu r r is cancelled out. R R but mu sine theta. Right? That means GR sine theta minus mu cos theta plus mu sine theta. This is V square min. V min equals what? GR sine theta minus mu cos theta plus mu sine theta. Well, root. Right? This is the equation. This is the equation. Okay. Right. Then we have to consider this case. The motion of the motorcycle in a motorhome well of death. Right? මේක දැකලා තියෙනවානේ මේ well of death එකේ මෙයා මෙහෙම යනකොට මෙයාගේ mg act කරනවා මෙහෙම. mg acts to downward direction. Right? mg and the reaction force act from this direction r. Then the friction force acts to this direction. It's like this. It's like this. See, F, mg, and r. The is also a circular motion, motorhome, and also we have to consider this case also, the rotor. When a man in the rotor, it also the same case. Okay, right. Write down another example. Well of death. Well of death. Right. Motion of a motorcycle in a motorhome. Motion of a object in a motorhome. Right. These are all the examples for the horizontal circular motion. Right. Write down. Here the required centripetal force. Here the required centripetal force to engage in a circular motion. Centripetal force to engage in a circular motion is supplied by a reaction force between well and the object. Well and the object. Right. Write down this one. Note down. Right. You have to consider this case. Right. The object is moving with v velocity along the circular path. Right. For this case, we have to apply F equals ma again. Apply F equals ma to center. Therefore, can we get R equals mv square over R. R equals mv square over R. Right. When mg f greater than to mg or f lesser than to mg, f lesser than to mg, that means frictional force. Okay, friction force lesser than to mg, the object coming or slip downward. Okay, right. When f smaller than to mg, the object slip over the surface, to avoid slip to avoid slip on the surface, F max should be greater than or equals to the mg. F max means the limiting equilibrium, limiting frictional force. F max is that one. Right. For that condition, we can tell F max is mu r greater than to equals to the mg. What is r? R equals mv square over r. Okay. R equals mv square over r. We can apply that one. From 1, mu r equals mv square over r equals to mg. Okay. Then p square gr over mu. V equals gr over mu. This is the minimum speed that can be traveled in the motor road or the well of depth. Why? If we reduce from this, if we reduce rather than this one, the object will fall. Why? The f get reduced like this, right? It is slip over the surface, right? Right now, V should be greater than or equals to gr over mu, right? Gr over mu. This is a minimum, or it should be greater than to that one. If it greater than to that one, the frictional force getting increased. Why? R got increased. That's why it's like that. Okay. This is the example. See, due to the centripetal force, this R does not fall. Right? Okay. Right. Rotor is like this. Right. This rotor is like this. When the cylinder is rotating, starting to spin. So the objects are getting like that. Flow is drop off. And they can stay. Flow is drop off. They can right. It's like that. Rotates like that. So there is a reaction force coming from the wall of the cylinder and the friction force and the engine. Right? Okay. Right. Write down the centripetal force, which can be required, which required to obtain circular motion, to obtain a circular motion, is given by the reaction force between object and well. Object and well. Right. In this case also we can apply. I apply F equals ma. So R equals m, not v. This omega square r. Right. Draw the diagram and write down that one. Then write down points. When f smaller than to mg, the object slipping off, will slipping off over the surface when f greater than or equals to mg, required to maintain a circular motion without slipping. Therefore, we can tell F max greater than or equals to mg, F max equals to mu r mg. That means mu r equals m omega square r greater than or equal to mg mm. Therefore, g over mu r equals to omega min greater than or equals to. This should be the minimum speed. Omega minimum speed equals to g mu r. Right? If they did not get this speed, the object will fall. මේ flow එක අයින් කරන්න පුළුවන් අපිට. මෙයා මෙහෙම කරගෙනකොට. හරි? මෙහෙම මේ ස්පීඩ් එකට වඩා අඩු වුණොත් එහෙම බෑ. Right? This is the equation. Right up. Okay. This example also, the mass of an object does not matter. See, there are types of when it got the velocity, the flow is drop out. Flow is drop out like that. The mass is not matter. The mass is not matter. Why? You can see the equation. No matter of mass. The equation there is a G over mu water. There is no M, right? Mass is does not matter. Okay. Right. These are the all about horizontal circular motions. Correct.